Good day and welcome to the Bearded AI Guide. Today we're learning Python game development with AI. This will be the first part in the series where we're going to look at the mechanics and developing a 2D car physics game. The interesting part with this will be using Claude Sonnet 3.5 as a comparison to what I used when I developed the book or wrote the book, Learn Python Game Development with ChatGPT. So this is a cover of my book, Learn Python Game with ChatGPT. I wrote this book some time ago, and when I initially started writing this book, I was using ChatGPT 3.5. So about half the book is developed with 3.5, and then as I progressed and decided that newer models were coming out quicker, that people will probably be using newer models, I transitioned to 4. I have since done a comparison in another video between GPT 4.0 and Claude Sonnet 3.5. For the examples and the demonstrations in this video, we're going to be using Claude Sonnet 3.5, which is kind of the best in practice model for developing code. Best practices developing code with AI. There's a number of things that'll make you more successful in developing code with AI, especially games. And it just comes down to a few techniques and devices that can assist you in the approach you take in how you develop any code with AI. So the first thing you want to do when you're developing any code is plan your feature. In the case of games, this really comes down to thinking about the primary game mechanics that are going to comprise your game. Think about if it's a 2D game, what controls will the players use to play the game? And then as you go through each iteration, you want to limit the number of features, gameplay features, that you introduce the AI through each iteration. So as an example, when you're doing your first iteration, I like to establish a precedent of just using 3 features. So I'll come up with 3 gameplay features, apply that to my primary prompt, and then as I go through each iteration, I'll only do maybe 1 or 2 features. You also want to make sure and test thoroughly each iteration as you're developing. You don't want to let one feature be not quite to your liking and just let it slide. You want to make sure that that feature is exactly what you want it to do. It's best to get these things developed well and in their code base before proceeding to more complex features. Maintaining code consistency. So making sure that your code isn't changing from one iteration to another, not extensively changing anyways. You want to make sure that the code is just iterating and building on top of feature by feature and not going major changes. If you find yourself making major changes in your code base as you're going through each piece, I would recommend going back and starting from the beginning. Primary thing I talk about in the book is being able to handle AI limitations. So a big limitation of AI in my experience is physics, complex boards like isometrics or hex games, and more non-standard development surfaces like 3D games that aren't popular with Python. There could be some other language that might be very popular. With Python though, 3D games haven't been very popular, hasn't been really good an engine to power 3D games. So that's sort of a limitation you want to be aware of before you even jump in, build your game. You also want to be able to understand, or you also want to have an understanding or willing to understand how your game will work. So if it's a physics-based game, you want to look and understand how the physics is going to work within the game. So that will most likely need to understand how rigid body physics work. And again, those types of things are covered in the book, Learn Python Game Development with ChatGPT. So the first game we'll be looking at is a 2D physics car game that I developed for the book. What you see in the corner is the finished product of what that game looked like. It included physics for the car, the vehicle, which included velocity and thrust for powering the vehicle, rotating the tires, as you can see, and then climbing up and jumping hills. The initial prompt I used to develop that game is what we'll be looking at and comparing to how Claude Sonnet might develop a first iteration or a first few iterations. In that initial prompt, write a 2D car game using Pygame and PyMod. Here are the features I would like. Car accelerates using the A key, brakes using the D. The camera and screen remain focused on the car, and car movement is demonstrating by moving the background. Use a blue background with white cloud. Let's take a look and see how Claude Sonnet handles that. Okay, everyone, here we are in Nexus. What you see here is I've copied and pasted the 2D car physics game prompt. I've created a new conversation thread to run, and now I'm going to select the agent. I'll choose the Python game developer. In previous videos, I've demonstrated this agent before. In Nexus, I can power this agent using various engines. These are the ones I've currently have set up. For the purposes of this demonstration, we're going to use Anthropic, and we're going to use the Claude Sonnet 3.5, which is currently the best in class. Just using default temperature, which is 0.7, top P1, and then actions, run Python code, run shell commands, so it could pip install things, and there's a separate install package command. Let's go ahead and run the prompt. Now, the Python game developer has the ability to run code locally, which means after it gets to a certain point and it can run code, it'll run the code and we'll see the game running in a separate window. I'm not going to demonstrate this in real time, so I'll probably edit out lagging and delays, but just know that it's generally reasonably quick. There it is, and you can see not much is really going on. I'm pressing the keys. I can move back and forth, but there's no ground plane, there's clouds, so actually not too bad. Okay, so let's close the window and let it continue. So what it's doing is it's going behind the scenes, and this is the logs, and this is what the agent behind the scenes is working with tools, using those tools to execute code, pip install packages if it needs to, like Pygame, for instance, and then come back with responses. So you can see it's such as the car control, camera and screen, background, and stuff like that. So actually not too bad. Okay, so what you can see here is I've extended the prompt for every iteration. Once I'm happy with that iteration, I'm going to add a couple more features to work on. So as I said before, you want to make sure that you have a good understanding of the gameplay mechanics for your game as you proceed and work through each iteration. We're fairly happy with what's been displayed right now. What I want to do is add a couple more gameplay mechanics and iterate. So we're going to run the prompt, and again, not running this in real time, so it'll come back in a few seconds. Okay, there's our car. Oh, it fell off. Okay, so what you can see there is what happened was the physics wasn't quite right, so the car wasn't really landing correctly or balancing out. Again, this would go through into another iteration. So as always, I'll just be polite. And I just want to correct that one feature so that the car lands correctly. Okay, I can move the vehicle. Actually, no, I don't think I can. Or maybe I am. I'm not sure what's happening. So the car just fell off. I'm going to stop there, demonstrating that actually not a bad working game. But let's look at what the original game looked like. Here's the original game, and a lot of what went into getting the original game to work correctly in the book was going through the physics, iterating on the physics, and understanding how the physics wasn't working correctly, including having the wheels rotate as the vehicle was moving, making sure the background moved, and so forth. The book goes over these techniques and explains the physics behind what we're trying to develop. Really, that's why I recommend the book for more complex games like this. Physics is a big problem in any AI-driven game that I've come across. I'll be very impressed when a game or an AI model can generate a game quickly with accurate physics. Okay, so what we've seen there is Claude Sonnet 3.5 building a 2D physics car game. It didn't do a bad job compared to other tools I've used before. Like I said before, I used originally ChatGPT 3.5, but really it's understanding the limitations of the AI. And as I've said before, physics games, isometric games, and 3D games are especially difficult to get right the first time, and usually requires some sort of in-depth knowledge of what you're building and how you're building it. Tools like ChatGPT and Claude Sonnet themselves can be very useful in helping you guide yourself in building these games, but also don't be afraid of looking at tools like my book and others. My book goes heavily in depth into developing physics games, isometric games, and 3D games. As always, thank you for watching. Please like, subscribe, and comment.